Good morning, pre-algebra kids. We're going to be starting into a new land. It's called the land of the parabola or the quadratic equation. We're going to start analyzing these things, and we need a few different ideas on how to analyze these things. The first part of this is just going ahead and graphing using a couple of pieces of information first. But I also want to talk to you about what a parabola is. Here's a parabola right here. It's this wonderful little graph right here, okay? And this graph has a few distinct details. One, it either points up or it points down. And when you see a quadratic equation, it's going to be written in a certain form. And I'm going to write that form down. It says it up here, but I'm going to rewrite it because it's really hard to see up here. This is going to be written in the form of f of x or y. I mean, this is the same thing. A function of x and y equal. Those things are the same thing. So I'm going to start talking about this. And when you see a quadratic equation, it has some x squared value. So ax squared, where a is the coefficient of the x squared term, plus bx, which is b is the coefficient of the x term, and plus c. And c is that constant. Well, guess what? That constant is also the y-intercept. So just like when we were talking about those linear equations, this constant here says if everything else is 0, if those x's are 0, where is it going to cross the y-axis? And so this y-intercept, this constant here, c, constant, tells us quite a bit. It gives us one piece of information. You can also look at this coefficient up in front of the x squared term, and it gives us another certain piece of information. If this is positive, if there's no negative sign, so a positive coefficient, I'm going to grab a different marker because this one isn't working very well. If this coefficient is positive, then our parabola is going to be pointing up, so it's a smiley face. Positive is happy, therefore, if you see a negative in front of this, it's going to be sad face, you know. Not very difficult, you know, you put little eyes on it. This is so sad. Anyway, sorry, losing my mind here. Now you understand. Positive, the parabola points up. Negative, the parabola points down. All right, so right now you've already got two pieces of information whenever you look at any quadratic equation. If there's nothing out here and it's just the x squared term, then you know that constant would be 0, or that y-intercept would be 0, so it would touch at the origin. And we'll get to that. We'll graph a few and we'll take a look. But I just want to make sure you understand a certain couple concepts. Positive means the parabola points up, negative means it points down, and we do have a y-intercept. Other than that, we have a few certain tricks in our bag. A parabola itself is symmetrical. It has a vertex, and one side is exactly the same as the other. So when you find that vertex and you start graphing by putting in inputs for x, it's not such a big deal to go ahead and say, well, this reflects directly across this parabola. And I'm going to show you how that works in just a second. But right now, I'm going to erase this. We're going to move on. And we're going to talk about one more concept. And that last concept is finding where that center point is, where that axis of symmetry is. And you can draw a dotted line in there like they've done here. They've drawn a dotted line in here where this axis of symmetry is. And all it says is if you fold up this parabola, it will fold right on top of itself. It'll show itself on the other side of that line of symmetry. And using that line of symmetry, we can find out where that vertex is, where that midpoint is of that parabola. And the last piece of information before I move on is if your parabola is positive and it's pointing up, then it has a minimum value. It has a minimum. So we say positive points up. It has a minimum right there. I'm just going to abbreviate it by writing the word min. And obviously, if it points down, this point right here at the top would be its maximum point, right? It can't go any higher, therefore it's its maximum. And so there are a couple of things we can write down when we analyze what these parabolas are, where they exist, and what we can do with them. And one last thing before I go ahead and start to graph one of these things using some information that we're given is all parabolas, all quadratic equations, unless they're specific, but all quadratic equations that we're going to work with have a domain that's infinite, okay? So that domain goes from negative infinity to positive infinity. The range, obviously, has to do with where the maximum or minimum of that parabola is, and then it extends on infinitely in the other direction. So let me just begin by turning around, moving this a little bit so that you can see a little bit more of what I'm talking about. To graph this quadratic function, what we're going to do is we're going to find the vertex, right? We're going to find the x-coordinate of the vertex, which is finding its axis of symmetry. And once we find that x-coordinate of its axis of symmetry, what we're going to do is we're going to take that x-coordinate and we're going to plug it into our quadratic equation. And what we get when we do the math with that x value in there is going to tell us where that vertex point is on the graph, and we can put a dot on the graph right there. So in this example, I don't know if you can see it, so I'm going to move on, and I'm just going to do this first problem, but what I need to do is blow it up so you can actually see it, right? I want to do all this work. Now, on your papers, you can see the formula for finding the axis of symmetry, and it's part of what is called the quadratic formula, and we'll get to that in a couple of days or so. But what I want to do is take that piece of the quadratic formula that tells us where that axis of symmetry is, and I want to write it up here. So I'm going to say for the axis of symmetry, and I'm just going to abbreviate it there, we're going to use negative b over 2 times a. Okay, well, that's a little weird to you, right? Because I've only shown you a little bit of what a, b, and c are. I'm going to write it over the top of this quadratic equation here, and I'm going to write over this so that you can see what this is. We have the quadratic equation x squared plus 6x plus 8, okay? And this is in that form, ax squared plus bx plus c equals some function of x or y. You know, when you put it into a calculator, where do you put it? You put it in the y equals section. So you have to remember that those two things are interchangeable. And here we go. We look for the coefficient in front of the x squared term, and that's just a 1. We look for the coefficient in front of the x term, that's 6. And we look for our constant, that's 8. Oh, hey, we know where our y-intercept is. Okay, so I'm going to go ahead, and before I even do any work whatsoever, I'm going to graph that y-intercept. On this graph, there aren't enough spaces. 1, 2, 3, 4, 5, 6, 7. I'm going to go up one more space, and I'm going to make a dot right here. Right? This point is 0, 8. Okay? Now, I have started to graph my parabola. The next thing I need to do is find my x value for my axis of symmetry. So I'm going to say x equals, just for fun, and then I'm going to take my 6, right? And I'm going to plug it in for b. So I'm going to say x equals negative, and put that 6 in there, and then that's all going to be over 2 times whatever a is, and a is just 1. So I'm going to plug in that 1, and I'm going to simplify this. And you see that negative 6, 2 times 1 is 2. And we have a value of negative 3. So my x coordinate is negative 3. And what I want to do is move over 3 spaces on the x-axis and create a dotted line to show my axis of symmetry. And I'm going to say we're going to use purple to show our axis of symmetry. I'm going to just show that dotted line like that, go to negative 3, and make a dotted line right down the negative 3 line. Okay. Right? So now we're set. What we have to do now, step 1 was use this formula. Step 2 is plug in negative 3 for x in our original equation. So we say, I'll keep the purple out just for writing stuff in, we're going to say y equals negative 3 squared plus 6 times negative 3 plus 8. All right, and this is going to get in my way a little bit, but I actually can do some of this math over here. I'm going to say 3 squared is 9 plus 6 times negative 3 is negative 18 plus 8. And 9 and 8 are 17, minus 18 is negative 1. So now I know that my y value, so y equals negative 1. So in my coordinate pair, that's my vertex. Vertex is negative 3, negative 1. So I found a whole lot of stuff, and I can put my point right down here at negative 1. And I have to have a couple more points to be able to graph my parabola, so I'm going to create a table. And I'm going to use that table and plug in values that are somewhere near this axis of symmetry. You know, I just said that my parabola is reflected across this axis of symmetry. So I can use one value and then reflect it over here, or I can put in both values. I can put in negative 2 and negative 4 and see what I get out. I can put in negative 1, and it's going to be the same thing as negative 5. So I'm going to show you how that works a couple of times, and then I'm going to move on. So I'm going to create this table. And I'm going to keep using my original equation. I'm going to get rid of this for now because it's in my way. Even this is in my way. And I'm going to keep using what I've got written up here. So I want to see what it's like if I put in a negative 2. A lot of people ask the question, why have you chosen a specific value to input for x? And I say to you that it's got to be somewhere on the x-axis near that axis of symmetry, near that vertex, near that midpoint. So if I know my axis of symmetry is 3, I'm gonna move out in both directions, just one place. So I'm going to try -2 and -4 and see what happens. I'm going to say, got to use a different marker. This should work. I'm going to say -4. How's that? We can't see that very much. Let's use red instead. Red or blue. They're a little bit darker. You can see it. Sorry for taking all this time. Blue looks good. Let's do -4 in the parentheses, -4, and leave that alone. So -4 squared is 16, plus -6 times 4 is 24, plus 8. Well, 16 plus 8 is 24, minus 24 gives me 0. So my input for -4 is 0. And now I'm going to erase real fast and do the same thing with -2. There's my -2. -2 squared is 4, plus -12, that's 6 times -2, plus 8. 4 and 8 are 12, minus 12. Hey, guess what? We have another 0. And just like I told you before, you can cheat as long as you know where that line of symmetry is or that axis of symmetry is. These two dots right here are going to be in the same place. They're going to be equidistant from that center. And so you don't really have to put in both -2 and -4. We already know that -3 is equal to -1. We already did that work. We could have put that first on our list. I'm going to go to -1, and I'm going to see what that is, which means all I have to do is erase that, and erase that, and we'll put in a -1. -1, oops, I'm doing it in the wrong color, but I don't care. -1 squared is 1. 6 times -1 is -6. And then we have our 8. 1 plus 8 is 9. 9 minus 6 is 3. And that's really important, right? We're going to see that this parabola is now taking shape. And we'll move out one more space and reflect it. So it's 2 spaces to the right of the axis of symmetry and up here at 3 on the y-axis, and we've just moved over 2 spaces from the axis of symmetry and done the same thing. And remember, we still have this y-intercept point of 0, 8, y-intercept. And now we have, we have enough points that we can go ahead and graph this guy, trying as hard as we can to just curve it around and make it look like something. Right? Is it perfect? No. But it gives you a good idea of what this parabola looks like. One, we knew it was positive because there's no negative here, etc., etc. Now, the last thing I need to talk about is, where is my vertex on the y-axis? It's right at, my vertex is at -1, so this is vertex, which is -3, -1. Okay, so its minimum is where that range would start. So we have a range of -1 to infinity. And of course, like I told you before, the domain is -infinity to +infinity. And that's really everything you need to know about graphing parabolas. If you have any questions, please go back over this. Please read a little bit. There are lots of videos on this. if this one's too long. It's 20 minutes long, and I really apologize. But I hope this helped you out.